Okay, so good afternoon, everyone. Welcome to the SuperMap webinar, SuperMap Mini Classroom webinar, Volume 6. And for today's session, we will discuss the SuperMap geology solutions, including for the hazard risk mapping and 3D geobody analysis. Okay, without any further ado, let's get started. But first, I would like to give you an introduction about SuperMap. So SuperMap was found in Beijing in the 1997, and for approximately 23 years, we already help humans in solving various problems encountered using GIS as the main foundation. We have 4,000 employees spreading in all around the world, 1,000 partners coming from the 30 countries, and 38 branch offices and subsidiaries. So we have 5 of our main key technologies that are the basis for solving spatial problems encountered using SuperMap platform. With the first one is the Big Data GIS. We support to do the whole process of big data, including streaming data, storage, databases, spatial analysis, and data visualization. And the second one is artificial intelligence and GIS integration. So in the SuperMap itself, we have our 3 functions for the AI and GIS integration, including GeoAI, AI for GIS, and GIS for AI. The third one is 3D GIS. So we have developed our function leads to 3D modeling from 2009 by integrating some technology like data model, scene construction, spatial analysis, and the software form. And the fourth one is the distributed GIS. So this value is just released in our GTC conference 2020 this September. So distributed GIS technology system in SuperMap has 4 components: the distributed geospatial data engine, geoblockchain, distributed geospatial analysis and processing technologies, cloud native and edge GIS technologies. And last is the cross-platform. So SuperMap is able to be open not only in Windows operating system, but in Linux operating system as well. So we used to abbreviate these 5 main key technologies into BDC, Big Data, AI GIS, 3D GIS, Distributed GIS, and cross-platform. Alright, and for today's session, we will discuss more on one of the SuperMap solutions for geology sector, about the hazard risk mapping, precisely for the landslide risk mapping and 3D geobody analysis. Okay, let's start with this slide. So maybe for some of you that coming from the geology sector familiar with this, so this is the illustration of the geology mapping. The left picture is for the 2D geology mapping and the right one is 3D geology mapping. So actually, geotechnology continues to play an important role in the study of Earth and all that is on the surface. Through the GIS, geologists have been able to identify and figure out the puzzle that is the Earth's surface. So let's take a look at some of the importance of GIS in geology and how geologists have harnessed the power of this technology to identify solutions, including geology mapping, geomorphology analysis, hazard risk mapping that we will do it today, geotechnical analysis, and so on. And in the SuperMap itself, actually we have our ready-to-use function that mounted in our desktop product, which is the SuperMap iDesktop. So in this, in our SuperMap iDesktop, we have some function, including the contour analysis, aspect and slope analysis, and also the plot simulation analysis that you can find in our SuperMap iDesktop, either the .NET version or the Java version. And you only need to import your digital elevation model data to the software and let the software to do the calculation by themselves. But for today's session, we will do more analysis, especially when we are doing the hazard risk mapping. So you can check our SMC Volume 3 video in SuperMap official YouTube because we already explain more details about the geology analysis in SuperMap in that are the ready-to-use function, the contour, the aspect and slope, and also flood simulation in the SMC Volume 3 video. Okay, now for today's session, we will discuss more details about our solutions for hazard risk mapping by scoring analysis and also the 3D geobody analysis. So the first analysis, the left one, the hazard risk mapping, is we will try to visualize which area has high potential hazard that will be visualized by aggregation grid map. But while the second analysis, the 3D geobody analysis, is more on the geotechnical analysis. So we will import our 3D points survey data and try to interpolate it and then visualize the result in the form of geobody. For today, we will use the SuperMap desktop product, the 10i version that available in our official website. You can download the products there and get the free 90 days trial license. So upon you download and install the software, it will be automatically 90 days trial version, and after that you need to purchase the license, or you can take advantage from your education license or others to keep using the SuperMap products. So you can go directly to our official website and download the installer, install it, and you can follow the instruction in today's session in order to achieve the geology solutions. Don't worry, I will share the material in the last presentation so you can try today's session by your own. So let's get started with the first one is the hazard risk mapping. So precisely this is for the landslide risk potential mapping with by 4 parameters including dampness, land cover, slope, and lithology parameters. And for the workflow in itself, first one, we will import the parameters data. So all of the data is in the form of a shapefile that already stored in the spatial database of SuperMap, namely data source. And then we will give score to each parameter. So actually, the method that we are going to do today is scoring analysis. So we will give score to each parameters, and then the next step is we will integrate all of the score in order to get the final score. So before that, we need to create a new grid and update its attribute field by parameter value. And then after that, we can get the final score by using intersect analysis. As we get the final score for each point, then we will try to visualize the score in each point by using the aggregation grid map visualization in SuperMap iDesktop. And last, to give you more clear illustration, we will add web-based map under the aggregation map, aggregation grid map. Okay, now I will go to my iDesktop. And anyway, should you have any questions related with today's session, you can drop your question in the Q&A chat box, and my colleague from the technical support team will try to answer your questions. So feel free to ask. Okay, now this is the SuperMap iDesktop 10i version. This is the latest one. It should be 10i.1 version that will officially release in our official website. So here I will not explain further about the introduction about iDesktop because yeah, you know, I have done that in the first webinar session, the SuperMap mini classroom first edition. And now I will go directly to open my data source. You can right click in the data sources and open the data source. So data source is SuperMap spatial database. I will open my data source, namely data. And if I expand the data source here, oh sorry, it should be not here. There are four data sets, namely dampness, land cover, lithology, slope, which are the parameters, and also the boundary. So now let's take a look at all of this data. You can select all of them and right click, add to new map. Why map? Because this data is the 2D data. Okay. Now we have 5 data sets here. I will show you one by one to get more details of each data. Start from the boundary. So the boundary is the boundary is our study area boundary. I've made this manually by digitize each corner of my study area. So it has 4 points here, and we will create the grid data set refer to this boundary. Okay, then let's take a look at the dampness. So this dampness, if we change the cursor into select cursor and open the properties to get to know more about which dampness is this area, such as this one. So this one is one of the dampness that has value. Okay. So each area here, it has a different value of dampness. So if you check to the dampness attributable, you can right click in the dampness and go to the attributable. This one. So there are 3 different dampness here: low, wet, and mid. Such as this one. This one is dampness with mid value, and this one is different. This one is wet. This one is low, and yeah, so each area it has a different value of dampness. Okay, now let's take a look at the slope one. So in the slope data set, there are 3 different slopes: the mountains, flatland, and hills, such as this one, and this one. Okay, and then lithology. It has 3 different lithology: pliable, resistant, and mid. Sorry, it should be this one. And the last one is land cover. So for the land cover, it has the total amount of the data is larger than the other. It has 22 records data, and if you check the data set, each area is have a different land cover, such as developed, undeveloped, and green area. Okay, so we have checked every data set here, and now I will show you the slide. So we will give score for each parameters, including for dampness, score, slope, lithology, and also the land cover. And after we give score for each subscore, for each subparameters, so low, mid, wet is I call them the subparameter, and dampness is parameters. And it will apply to others too, such as flatland, hills, and mountain is subparameter, and slope is the parameters. So we will give score for each subparameter and integrate all of them by using this final score. So this final score is give the weight value for each parameters, such as 5 for lithology, 4 for slope, 3 for dampness, and 2 for the land cover. So now we go back to the SuperMap iDesktop. and start to giving score for each sub-parameters. Okay, if you open one of the data here, such as the dampness, before we give the score for each sub-parameters, we need to add a new field here that after that we will give the score in that new field. So you can go to the attribute table of the dampness. Make sure here you are opening the dampness attribute table, and under the properties window in the right side, in the attribute table, you can add new field, namely dampness score, for example, and change the type into a number type such as double. Or maybe if you willing to give an integer score or others, you can do that based on your requirements. And then you can click apply and go back to the score rules. For the dampness, low dampness will be giving 1 score, mid 2, and the wet one is 3. Okay. So since this is only 12 data, that's not that much. We can just type the value manually. Low 1, mid 2, and the wet 3. I will show you how to update the attribute in the land cover dataset because it has a larger total data than the dampness dataset. Okay, now we're done for the dampness. We will go to the land cover because this data has 22 records, and it may take time to give the land cover score one by one. So we will try to query this data set based on the land cover value and giving the score for each sub-parameters. So now just the same like the previous dampness, we will add new field, namely land cover score. The type should be the number type. We can use double. And now we will do query for this. You can go to the data. Spatial analysis, and then query, and select the SQL query. Make sure in the select dataset you select the land cover. You can clear this in case you have done previous query. It's still stored here, so you can do clear. You can click the clear button first. And now we will select all of the land cover where the land covers. When the land cover field equal to, you can get the unique value for this land cover field when the land cover field equal to develop. So we will do the score. We will fill the score for the developed area first, and for the show results, you can browse the attribute tab instead of the others, and then click query, and the new tab will appear here for the developed land cover only. And for the developed land cover only, the score is 3. So you can select this field, right click, update field, and in this update field function, in the operation method, you can use the assign to all because it will assign one value for all of the records data. So in the operation value, you can type 3 because the score for the developed area is 3, and then click apply. Now do the same process for the rest land cover, including the undeveloped and green area. Okay. So for undeveloped is 2. You can update its value into 2. And the last one is the green area. and the green area, it has value 1. We will type 1 in the operation value, and it will give 1 value for the whole green area data. Okay, now we'll close this attributable because I already put all of the score for all of the land cover records data. Now we'll close this and go back to my map. Okay, now we'll go to the third parameters, that is the lithology. We can browse its attributable, add new field, namely lithology score, change the type into double and click apply. And for the lithology, the pliable is 1, mid 2, and the resistant is 3. Okay, pliable 1, middle 2, and the resistant is 3. And the last one is should be the slope. You can open the attribute table, add a new field, namely slope score, change the type of the field into double, or you can change other in case you're willing to give a specific value of the score, and then click apply. And for the slope, the flat land is 1, hills 2, and the mountain is 3. Okay, now we already give score for each parameters. So next we will try to integrate all the parameters in order to get the final score. To achieve that, we will need to create a grid points first. So each grid points then will store each parameter's value. You can go to you need to create a grid by using this function map grid. You can go to the maps menu, and under the mapping ribbon menu, you will find the map grid. You can open the map grid function here. And since we already have our boundary points data set, we can set this as the extend boundary. So the type here, we can choose the use specified data set range and select the boundary. So the result will be created refer to the boundary as the extent. And now we can define the total number of column and rows. This time I will use 20. And anyway, we can also change the grid type here, graticals or measure grids, but I will use the graticals instead. And in the advanced menu here, we can change the type into whatever we want. We can choose the point, line, region, or cat. This time I will use point. And in the result settings, you can select in what data source you're willing to store your grid data set. And I will store it in the data source with the name map grid. Or maybe change into grid. Okay, and then click OK. Okay, now this is the result. The grid already created refer to the boundary extent. We can turn off the boundary extent and other layer. So this is how the grid looks like, 20 by 20. So it should be 400 points here. And we will store each parameter's value that intersected with this point for each point, such as this one. So as you can see here, these points is intersected with this area of dampness, which this area of dampness has score 1. So this point, then we will store this dampness score to this point. And also for others parameters such as this one, in this point it has slope score 3, so we will store the slope score to these points, and so on for the lithology and also land cover. But if you notice in the boundary points, it's quite tricky because not all of the points, such as this one, we can turn off the boundary, such as this one is not intersected with others with this data set. This point is only intersected with the lithology data set. Therefore, to make our analysis better, we can just delete the boundary points, such as here, here and in the bottom and in the left side. But before that, we need to activate our editing pen tools. You can double click here until the pen is changed into blue, and then start to select the, or maybe we can turn off others layer, and then select the outer points in all of the side, in the bottom, in the top, in the left, and in the right. And after that, you can right click and delete. So now we already make sure our points, all of the points is intersected with the parameters. Okay, next process is we will update the points attribute table. Refer to each parameters score in each data set. You can go to the data, and here we have the dataset attribute update function. You can open this function. First, you will be asked to select what data with attributes offered. So here, the data with attributes that going to be stored in our grid is the dampness, land cover, lithology, and slope as well. So we will do one by one for the dampness, land cover, lithology, and slope. Start with the first one is we will do for the dampness. So dampness is data with attribute offered for this type. And the target data is the grid, our grid. In the parameter setting, we will use the intersect. So each point which intersect with the dampness dataset will we will assign the dampness information to the grid dataset for each point which is intersected with it. So here in the get value method, we can use the assign. In the field setting, this is important. Make sure if you give a check in the dampness score or the field score for all of the parameters later. So we will give a check here. And since in our grid dataset, we still have no attribute, we still have no field here, so we can create a new field, and the dampness score field from the dampness dataset will be assigned to the grid dataset for each point which is intersected each other, and then we can click OK. Now let's take a look at the grid attribute table. So each point now already stored the dampness score. And we will do the same process for the rest parameters, including land cover, lithology, and also slope. Okay, I will make it fast. Land cover, grid, intersect, assign value. The third one is lithology. Please change the target data into grid, intersect. And the last one is for the slope. Okay, now let's take a look at the grid attribute table. It already stored 4 different score for each dampness, land cover, lithology, and slope as well. So in the next process, if you remember my slide, we will calculate the final score by using this function. We will give weight for each parameters, 5 for the lithology, 4 for the slope, 3 for the dampness, and 2 for the land cover. So now go back to the array stop here. We need to create a new field, namely final score. And click apply. And we will update this field by using the final score function in my slide previously, by giving different weight for each parameters. So how to update that? You can right click in this field and then update field. Make sure is in the update field column here, you select the final score. In the operation method, we use function. And in the function, you can click more. And now we will put this final score function to the SuperMap iDesktop in the SQL expression here. So open new bracket, giving 5 for the 5 multiple by lithology. So lithology is have the weight for the lithology is 5, close brackets, and plus by 4. You will give 4 for the slope, plus open bracket, and then we will give 3 for the dampness, and 2 for the land cover. And then click OK, apply, and close the SQL expression. And here we already get the final score for each records data in the grid dataset. And after this, it will visualize different color by using the SuperMap aggregation grid map for each dataset here. So here we will go back to the map. We can turn off other layer except the grid dataset. And to create the aggregation grid map, we need to create a new thematic map layer. You can right click in the grid layer and then create thematic map. Go to the aggregation map, and we will use the grid aggregation map. So actually aggregation map in SuperMap is basically the density relative visualization. So if you zoom in and zoom out your map, it will give you the different visualization for the heat map or the grid aggregation map. So that's why it's called the density relative visualization. Actually, for this point, you also able to give the heat map visualization, but for this time, we will use the grid aggregation map instead. You can try the heat map by your own later. So by using this grid aggregation map, it will give you this kind of visualization. So each grid will represent point that intersected with this, such as if we zoom into the map, each grid here, it will represent the statistic information of 2 points under this grid. Okay, in the layer properties of our grid thematic layer here, we will change the parameter setting. So in the grid field, we will represent the final score. So that's why we will use the final score here as the grid field. And the aggregate function, you can represent some statistic here. You can do sum, mean, count, max, minimum, or this one to represent the statistic value for each grid. And for this time, we will use the mean. So this value is the average value of points that intersected with the grid. And for the grid type, you can choose between quadrangle or hexagon. I will use the hexagon instead. It's will change into like this. And for the color, it will give no color for data that has no value and has no value or a lower value, and give a red color for data with high value, such as this one. So that's why we call this density relative visualization, because if you zoom in and zoom out, it will give you the different result. And you're also able to change further settings such as the label. In case you're willing to change the font size, the tilt angle, and etc., you can do that here. Okay, we can turn off the grid data set here. So actually this is the final result, but in order to give you more to give you more understanding on this map, maybe better for us to give the web-based map here. So we can add a new web data source by right-click in the data sources, open web data source, and we can select the OpenStreetMap and click OK. So if you expand this, there are three different maps: the standard, the cycle map, and transport map. And we will use the standard instead. You can right click and add to current map. So if the prompts appear whether to open dynamic projection, you can click yes, because maybe in this case the OpenStreetMap projection system and our data is different. But by using this dynamic projection, it will not change the coordinate system of each data set, but only um, for the representation needs, it will give you visualization looks like all of them is well overlaid. So you can click yes and change the map order at the bottom. Okay, yeah, so this one, the final result. This is case in Indonesia. So we try to visualize area with high probability of landslide hazard. So as you can see here, area with a grid color red, it means that that area it has a high probability to get landslide hazard, and for area which has yellow color, it more safe rather than the red one. Okay, you can explore more about this because this coding method is very useful not only for hazard mapping but also for others. Actually, in the previous session of SMC, we ever using this method for doing the election mapping. You can have a look in our SuperMap official YouTube for more details about the video. Okay, this is for today's first session about the hazard risk mapping. Should you have any question, you can drop your question in the Q&A chat box. Okay, now we will go back to my presentation. So for geology, that is the first one, the hazard risk mapping. Okay, and the second session, we will discuss the 3D geobody analysis. So this function is very useful for geologists. We will try to make the geobody making, and we will try to make the geobody based on the 3D points data that store information about the soil, different soil layer, and then do the profile and borehole analysis for the geobody result. So this is how the workflow. Yeah, so first we will import the 3D points, create the area boundary. So we will create the geobody based on this boundary, and then do the geobody making. This we will create line for profile extraction, do the profile analysis, create point for borehole analysis, and the last one is borehole analysis. So as you can see here, every time before before we making the geobody or do the analysis for the geobody, we need to create a data set either for the area boundary or for the line or the point in order to achieve the analysis of the geobody. And the data set and the area boundary, the line for the profile extraction or the point for the borehole extraction is in the form of 2D data, so you don't need to create it in 3D, but the geobody itself is a 3D model. So now without any further explanation, we can go back to the SuperMap iDesktop. Okay, I will open my data source. I have stored the 3D points data to make the geobody in this data source. Okay, now I have opened the geology data source. And in the geology data source, as you can see here, I have 5 different points. The symbol is quite different with these points, right? So this is for 3D points. And this is how SuperMap represent the SuperMap symbol represent the 3D points. It difference. So this five different soil, we will try to represent this by a geobody. But before that, let's take a look how it looks like in 2D map and also 3D scene. First, I will show you how it looks like in 2D map. You can select all of this data, right click and add to new map. So here, this is the distribution of the data points data set here, including pebble, clay, coarse, blending soil, and start point. And all of them, it looks like only one kind of point, but actually it was not. So if we, so all of this point is in the same position, but in the different height. So each point here has 5 different layers: clay, pebble, coarse, start point, and planting soil. So maybe it will be more clearer if we open this data set in a 3D scene. You can right click and add to new spherical scene. Okay, zoom to the layer. Now use your mouse scroll to change the tilt angle so you can get more experience, good experience in understanding this 3D data. Okay, such as I will select this area. So as you can see here, one point in the same x and y coordinates is store different information of soil. The top one is should be the start point, and the second one is planting soil, coarse, clay, and the bottom one is the pebble. So if you see here, actually in the same position of x and y, it has different 5 soil layer, but it will give you more clearer if you open the data in the 3D scene, such as this one. Okay, and now we will create the geobody first. To create the geobody, actually we can create a geobody for the whole area, but it will take time. So for this time, I will try to create the geobody for the just a little area such as this one. So before I create the geobody, I need to define the boundary. So to do that, we can create a new data set, region data set that and draw it and draw the boundary of our geobody. Okay, we will go back to the 2D map here. Okay, to create the boundary, we can create a new data set. Right click in our data source, new data set, and we can select the type into region and change the data set name into boundary. Create. And if we check the coordinate system of this boundary, you can right click and open the properties here. In the coordinate tab, it's still in the planar coordinate system. We need to define this coordinate system first before set this as our geobody extend boundary. To do so, you can just copy the coordinate system from others dataset. Since the others dataset including pebble, clay, coarse, planting soil, and start point is in the same coordinate system, so we can select just one of them. In the data source, please make sure you select the geology data source, and you can select one of them. All of them is in the same coordinate system, and then click OK. So now the boundary is already have the coordinate system similar to others dataset. Okay, we will now we'll add this dataset to the map. You can directly drag it to the map and change the order into the bottom. To create the boundary, we will do the digitation. Activate the pen editing tools until the color change into blue. And in the object operations, please click in the region, and you can start to digitize the boundary. Okay, I will draw it here, and you can right click when you're done. So this is our boundary. We will create the geobody refer to this boundary. Okay, now we will go back to the 3D scene. To make the geobody, you can go to the 3D data, in the 3D data, and then you will find the geobody here. So the geologic body will be created based on the 3D points. And as you can see here, the geologic profile and the geologic borehole is not activated yet because we have no geologic body in this project file. So that's why we still unable to open the geologic profile and geologic borehole function. But if we have created the geologic body, then these two functions will be active. Okay, now we will create the geologic body. Firstly, we will import the points you can add and select all of these points, then click OK. So when you're making the geologic body, one important thing is this order is this order will affect the result. So in the first number, it should be the top layer. And in this case, the top layer is not pebble, but start point. So you can select in the start point and click on the top button to make this data set in the top position. And under the start point is planting soil, and then coarse, clay, and pebble. So please make sure if you change the order correctly, or otherwise you will not be able to get a good result. So yeah, I would like to repeat that the order will represent the result. So the first one, it should be the top, and the fifth one, it should be the bottom layer. And we can define the extent here. Actually, you can set it default, but since previously we already create the boundary dataset as our geobody boundary, so here we will use that. We will create the geobody with our boundary data set. And in the parameter setting, we can change the color result. You can give a check in the color scheme. And actually in SuperMap, you can find so many color scheme here. But you're also able to define your own color scheme. So you can click custom here. And since we have 5 different layers for pebble, clay, coarse, planting soil, and start point, so I will add 5 different color. And to change the color, you can just double click here and change the color. For the first one, I'm going to have a red color, and the second one is yellow, and then green, and then purple, and the last one is blue. Okay, so if you finish, you can click OK. So now I have defined my own color scheme, and also import the points, of course, set the boundary, and the last one, we can change the result data name, in which data source we will going to store the result, and also we can change the name. Okay, I will not change the name, so it will give us the geobody result names for the result geobody data. Okay, now I will click OK and wait until the process successfully complete. And it will appear here under the geology data source. Okay, I will import this to the scene, because this is, as you can see here, this is the symbol for the 3D model. So that's why this is only able to be open. It can be opened not only in scene but also in map. Okay, you can use your scroll mouse to change the tilt angle. Maybe we can just turn off the other layer. Maybe because of the teleconference teleconference limitation, it not runs smoothly in your screen, but actually if you can try this by your own in your computer, it runs very smoothly. Maybe for geology people, they can do further analysis if they encounter such as this situation when there are three different or more layer is encountered in the same position. So each layer will give you different colors as you define in the color scheme setting. You can turn off the visible here to get in order to off the sun effect. So here for this layer we can find 5 different layer, 1, 2, 3, 4, and 5. So actually basically the software is do kind of interpolation for the data and visualize it by using this geology body. So maybe you can try this by your own, if or in case you have your own survey data that in the form of 3D points, you can give the visualization by using this geobody making feature function in SuperMap iDesktop. Okay, after we get the geobody, we can do further analysis for this. So if you go to the 3D data, here the geologic profile and geologic borehole is active. Because we already have our geology body. So that's why the geologic profile and geologic borehole is now active mode. So we will do the profile and borehole analysis for our geology body. But before that, we need to create a line before we do the geologic profile, and we need to create a point before we do the geologic borehole. So we can go back to our 2D maps here. Okay, here we will create new data set, point data set, and line data set. Point for borehole analysis and line for the profile analysis. So you can right click in the geology, new data set. First one is point. Here we can change the name into borehole. And the second one, we can create line, profile, and then click create. And 2 new data sets appear here under the geology data source. And since this still in the planar coordinate system, we will define the coordinate system by copy it from other data sets. So you just only need to copy it from others. Make sure it is from the geology data source. And for example, from Pebble data set. Okay, so now we already defined the coordinate system for the borehole and for profile dataset. We can import both of them to the map. And now we will edit each layer. Firstly, for the profile, better we close all of the layer except the boundary. So just the process is same, just we will when we do the digitation for the boundary. So we need to double click in the pen editing tools to activate it, and in the drawing we select the line because this is a profile, and we can draw some line. You can right click when you finish or double click. I think right click. So every time you finish digitize, you can right click. So here we will create the profile of our geobody refer to this profile line. And now we will edit the borehole. So you can activate the pen editing tools and click the point drawing and start to draw the borehole. The borehole distribution, such as, for example, like this. You can of course make more denser. right click when you finish. Okay, so maybe we can give one more here. All right. Okay, right click when you finish. And now we already create the borehole distribution points and also the profile line. We can go back to our 3D scene, which the geobody is illustrate. So go to the 3D data and we will do the geology profile analysis first. You can open the geology profile, and first you will be asked to put the source data, and here it only able to select the 3D model data, which is the geobody results for this case. And in the profile data, we will use the our profile data set that we already created before. And here you're also able to change the thickness of your profile section, and also the altitude. So this is a starting point of altitude. So in case you are not willing to get the profile from the bottom, maybe from some meters above the lowest layer, you can define it in the altitude number here. And in the result setting, you can change where you willing to store the result, and also change the data set name. And you can click OK if you have done set the parameters. Wait until it's successfully completed, and it will be appeared under the geology data source. Here, as you can see in the left window, the profile result. You can right click and add to current scene, or just directly drag it to our window. Okay, maybe we can turn off our geobody. So this is how the geobody looks like. The geobody profile looks like. So it was like we are doing a cross section for our geobody. Refer to our line data set. So now you can know the vertical sections of our geobody, such as like this. Okay. And last we will do the borehole analysis. So you can go to the geobody tools and click the geologic borehole. And in the parameter setting, you can select the borehole dataset that we already created before. And here you can change the diameter of the borehole result, and also the altitude number. So just like before, if you're willing to not get the borehole result from the lowest layer, maybe a number above the lowest layer, you can define it in the altitude number here. And you're also able to change the result setting, the data source, and also the file result name. And then you can click OK. And wait until it's successfully completed. Maybe it's quite long because I put so many points in this area. So now this is the result, the borehole result. So now let's take a look how it looks like. Oh wait, I think I have a problem here. Okay, maybe we can try to repeat this again. Okay, make sure if it already have the coordinate system. And now we will try to create it again. Okay, and this is the borehole result. So the borehole result is will give you the representation of the layer under each point that you have defined in your profile in your borehole dataset, such as this one. So this borehole, this one borehole is represent one point in your borehole dataset. And yeah, it actually it also doing the cross section. So as you can see here, it has a different layer, the red one, the orange, the yellow, and also the green. So maybe it's quite different if we are using the profile analysis. It will give you you need to import the line as the source data, but if you are willing to do the borehole analysis, you need to import the point data set. So that's all for today's session. I will share the material, and also I will share the data for you. Also, you can try today's tutorial by your own in your own computer, and you can submit them to the link in order to get the certificate. So I will go back to my presentation. Okay, actually, I will have another information about the geobody. So actually, if you're willing to do the application development level, so it's different with the one that we done today. So today we only working in SuperMap desktop products, but if you have your ability to do some development, you can check the SuperMap iClient website. It store many source code here, and if you go to the KML and model menu, you will find if our geology body analysis is not only able to do the geobody making, not only for borehole analysis and also profile analysis, but more than that, we also able to do the real-time profile and borehole generation, cross-sectioning, excavation, and vertical excavation. But actually, for this cross-sectioning, excavation, and vertical excavation is only able to be achieved for the application developments, but not exist yet in the SuperMap iDesktop. So how it looks like, you can see here. This one is for the real-time boreholes generation. So if you have your geobody model, and then you can directly put some points in your geobody, above your geobody, and the software and the platform will automatically generate the boreholes, not only boreholes but also profile. So the user can draw the profile line that they willing to generate the profile, and then the software will generate the profile directly upon you finish to draw the line. And then the next one is the cross-sectioning and also the excavation. So in the cross-sectioning, it's quite similar with the profile analysis. And in the excavation, you can such escape your geobody, and you can have a look how it looks like in each layer of your escape boundary. And also the vertical exaggeration, you can define the depth here and do the exaggeration for your 3D geobody vertically. And also explosion. So by using this explosion, you can get to know how each layer looks like. So it may not have a smooth surface, but of course not, because it depends on the real situation, right? Okay, so that's all for today. Thank you so much for your attention. Thank you for joining our today's session. So you can download the material in the link attached in this presentation in the bit.ly/smcweb_material. In that link, we have stored all of the materials start from the SMC1 until today SMC6. So you can find the SMC volume 6 folder to access today material. And also if you have successfully attempt today tutorial, you can submit yours in the SMC web submission link attached in this presentation before the due date. It should be before the 7th of November 2020. So participants who submit their result will get certificate from us, official certificates. And in case you have any question related with today's session, but you don't have time to put your question in the Q&A chat box, you can directly reach me in my email in gandes@supermap.com. Or you can also visit our website to get more information about SuperMap products and capabilities. Okay, thank you all for today, and see you in the next SMC.